process, whatever we discuss, many complexity may arrive, because in real life it may not be simple like whatever we are assuming. Now, what are these complexities? First of all, the image, whatever we are having, that recognize to be recognized image must be steady, at least in one instance. Again, its properties should be constant, unique. Then, second part, the scene constancy, that is what we are talking. So, at least for one frame of camera, that particular moment we must get where we can capture the image. And again, similar thing should appear in our model database. Another part, the images what we are talking are generally 2D, but outside world can be of 3D or more dimensions. So there are so many possibilities can be there. For example, a nut which is coming or a bolt which is coming on conveyor can have various views to recognize. This occurs because on the conveyor the object is in 3D, but camera looks it as in 2D. This is one more problem that model faces. Then number of objects in model database. If our reference images are too large, then delay is there and accuracy will be also less. Similarly, how many features are in the image? How many things you are matching? That is also another part. Another thing, what is exactly distinction or differentness of that particular feature in the object? That is also considerable part. That's why all this process becomes very, very difficult in practical. Still, we try to match in this real time process. Now, first problem, what we said is scene constancy. First of all, there are two parts. Your objects are moving or steady. In case of steady objects, we can receive great accuracy. But in case of dynamic objects, scene complexity will be very important parameter, because for matching up two images, that is input image and reference image, the images must be having or images must be acquired in similar conditions, that the illumination, background, camera parameters, the viewpoint. That's why you can see importance of fixing the camera either on fixed camera position or on the tool mounted camera position. So angle of capturing image, at that point what is illumination, how much light is falling, at that time which part of conveyor acts as a background, and after all what we have detected, that is the parameters, because resolution of the camera and other properties of camera also important, and all these things practically must match or they has to be matched. That's why scene constancy is very, very important. Many of times in our practicality, the object is made slow whenever it is to be detected, so that you can get preferable angle, or many mechanical arrangements are done in dynamic environment so that object lies in similar angle to camera. Next part is model spaces. As we said that we are observing 3D objects, and now our views, our images are 2D images. So we need to resolve this overlap. We need to resolve these cases, especially as on when it happens. So 3D view definitely is preferable, but again it increases delay in the recognition process. So dynamic images, that is what object is in motion, will be creating such problems. Another part, how many objects are there in model database? If you have huge database system, then it will take time to verify, because this verification is sequential process. The matching goes exhaustive if I have more number of objects to be matched. So problem is that it will increase time. On the contrary, in robotics vision, we need real time operation, that is dynamic operation, because our next operations are depending on that. So how to solve this problem? To solve this problem, we have to select appropriate features. We have to use fast cameras. You have to use correct object recognition strategy. So even if larger number of objects are there, still accuracy can be increased. But in a practical case, if you ask me, if object numbers are large, then object recognition process is always delayed. There are some more things are there. There are overlaps. Whenever many objects are there, or view is having many objects together. For example, in sorting operation, so you can see there are overlaps in images. So what camera is captured like this, but actually this is not like that. So this overlap is another problem, that is what called as occlusion. So whenever we are having sorting operations in robotics, component sorting or machine component sorting, so at that time we have to resolve overlap problems also. Two-dimensional views and three-dimensional views, we talked on this. Decomposition, again one more problem, or gives complexity. Three-dimensional views again increases time, it gives perspective effect and viewpoints also, but again we need higher camera systems and structured objects are required. After discussing all these problems, next part is how to represent object.